Hey guys, and welcome to one more episode of Builder Nation. For today's agenda, we have Elliott Rouse, Assistant Professor at the University of Michigan, Technical Advisor at Google X, and Director of the Neurotics Lab. Welcome, Elliott. Super happy to have you here today.
Thank you. I'm really happy to be here. I appreciate the invite. I'm Elliott Rouse. Like you said, I'm a professor at the University of Michigan, and I run this research group. I would say kind of the driving force behind our work is really kind of making people's lives better. So that was maybe something that came from some of my previous experience, which we could talk about if you're interested. But we used to work in professional auto racing. I loved that job and it was an amazing experience, but I felt kind of a pull to have my work impact the lives of people with disabilities and others. That kind of led me to go back to graduate school, and the rest is history. Now I run this group outside of work. I have a wife and two great boys. So that's kind of what, between work and my family, that kind of occupies like all the time I have.
Oh, that's great. And I mean, you said that if we wanted to, you can share that experience. And that actually was my next question. Like, what got you into robotics? What is the main motivation? Yeah.
Yeah. So I was always like pretty mechanically inclined. And I kind of funneled that when I was young into being an auto mechanic. So I was an auto mechanic through high school. That was kind of my high school job. And then when I got into college, I ended up through kind of a chain of events becoming a mechanic for an auto racing team that traveled kind of around North America. I did some racing in Western Europe. So that was an amazing experience. I learned a ton of hands-on skills. I was there for about 4 years. So I kind of did full-time auto racing and I did full-time school, but school was kind of the more side part. I was really kind of focused on auto racing at the time. And over that 4 years of working there, despite how exciting and interesting it was, I really felt this pull to have my tangible work kind of benefit people kind of more directly. And I felt a particular calling to people with disabilities. So I followed that passion into grad school. I was captivated by a medical scientist named Dr. Todd Kuiken, who had developed a surgery to kind of rewire people's nerves. And I talked him into letting me be his grad student. And at that point I switched. So I went from kind of being a mechanic and working in auto racing into kind of a track to be a scientist and an engineer solving rehabilitation challenges. And that's kind of my story for getting into it.
Wow. At the same time, I mean, in the meantime, while being married, having kids, I mean, applying, then I saw that you gave a TEDx talk about it. And I mean, first things first, how did you end up at Google X as a technical advisor? That's super interesting.
Oh yeah, that was a blast. So that actually came through a connection I made at a conference. So I was at a conference a few years ago and saw someone named Catherine Zealand and kind of spoke with her a little bit. I kind of gathered what she was doing. She was kind of doing some background research into this area, and we just connected and started chatting. And I kind of learned more about what they were doing. They were investigating whether they should kind of put some resources and some effort behind this area of work, assistive technology and rehabilitation. So we started talking more and more, and eventually the project gained some steam at X. And then they wanted to form a team and actually kind of invest some resources more seriously. So I joined over there for about a year. I was flying back and forth between Michigan and California. And then now that was probably from maybe 2020. That was kind of around 2019, 2020, kind of that span. And then I left to come back to Michigan. And I've been advising them ever since. They're doing a great job. They just kind of passed a major milestone, which was very exciting. So that was a great experience. And now it's kind of more of an advisory kind of role for me, more high-level strategy. And when I was there, it was more helping Catherine kind of form the team and sketch out kind of a research vision.
Wow. And they're also doing robotics in that research, or?
I can't really talk much about what they're actually doing, but in general, X does robotics work. Yes.
Wow, that's great. And I mean, talking about your specific research, I saw that you had like 2 specific ones that I think one you mentioned they mentioned in the TEDx. One is the bionic knee research, and the other one it's related to dancing. So can you share a little bit?
Yeah, so the dancing, I worked, that project is hosted on my website, which I kind of created as I was looking for academic jobs. So I haven't updated it much kind of in the past few years, but my research lab website now probably serves that function. But that project was while I was a postdoctoral fellow at the biomechatronics group at the MIT Media Lab. So I was there for a few years after I finished my PhD. And while I was there, that was 2012 to 2014, was the Boston Marathon terrorist attack. So that was maybe the last year I think I was there. And we wanted to kind of give back to the community. We felt particularly compelled. A lot of people had lost limbs, and we were kind of a lab that specializes in advanced prostheses for people with amputation. So we kind of wanted to get in there and help. So we, through in kind of a series of connections, found Adrienne Hazlitt Davis, who was formerly a professional dancer before she lost her leg below the knee in the terrorist attack. And we kind of wanted to use some of our robotic tools to give some of that functionality back, at least to the best extent that we could. And that's what we did. So we developed a controller. We analyzed the way professional dancers move and how their joints respond and interact with the ground. And we programmed a robotic ankle prosthesis to kind of behave that way. And she returned to the dance floor. We demoed that at the TED conference, which was fantastic. It was a beautiful and wonderful project to work on.
It was definitely a great one. I mean, I saw her face and she was nothing but grateful. And, you know, everyone was really moved about it. So I think that applying robotics into the human part of it, I think it's also great. Mm-hmm. And talking about the technical side, like how hard it was to build a robotic ankle and knee and how does it work?
Yeah, so maybe for that, I'll talk about some of our newer project we have, which is the development of an open source robotic leg. That's been kind of going on for maybe the past few years. The impetus for that project was really that the control of these systems is their major barrier, getting them to act intelligently so that they don't let a person fall to the floor or fall down a set of stairs. That's very, very challenging. It's kind of a different game than some of the upper limb prostheses that don't have that constraint of holding the body up. So we wanted to provide a hardware platform to researchers around the world who could study these control challenges and answer them, so that we could get this technology out into people's lives. So we developed a mechanical test bed. So basically a robotic knee ankle prosthesis that's been designed from the ground up to be easily manufactured, assembled, and controlled. And we have a pretty extensive website that's opensourceleg.com. And it includes all the information to build one yourself. So all the part files, drawings, bill of materials. There's assembly instructions, detailed videos teaching somebody how to assemble and disassemble it. There's control files, so software you can download, and videos demonstrating how the software works. So it's actually developing the website was probably the biggest undertaking of that entire project. But that was a fantastic experience. Now we developed one leg, one design, and it did well. And then we have now developed a second design based on some things that have been developed in the meantime. And our second design is now released on the website. It's also being commercialized by a company called Humotech that works in our space, so that for people who don't want to build it themselves, which is probably a fair number of
people who don't know how to build it.
So they can now just buy it from this company, Humotech. But that robotic leg is kind of intended for researchers, at least at this point. There's no pathway for that to get out of the lab and into lives of patients. It's more of a research platform to accelerate the research that's going on in the control side.
Wow, this is really interesting. And I mean, what are the greatest questions we can start to answer with this open source leg?
It would be, the greatest questions are, how does the leg know what to do? So when someone's walking, it has to provide what are sort of cyclic patterns of motion and effort. And it has to know, are you walking? So a common way to break up this problem is to say, let's first decide what activity someone's doing. And then once we know that, we have an activity specific control strategy that we would use. So always it would be trying to figure out, is someone walking? Are they standing? Are they about to go upstairs? Are they going up an incline or a decline? So it's kind of always running that intelligence behind the scenes. The greatest advancements would be one, to solve that challenge, so that we could Like right now we have systems that are 99%, even greater, 99 point something accurate, but that still means one step in 100 to one step in 1,000, there's a mistake, which could be catastrophic. So we need to kind of solve that control problem, but then higher or maybe bigger picture, I think the greatest improvements will come in the future when we can directly link these systems to the human nervous system. Right now, that's not possible because information coming from the nervous system is really uncertain. It's really unclear. So a lot of intelligence goes in to figure out whether those commands or signals being sent are accurate, or whether we know what they're actually saying or decoding. So for the lower limb, we don't use neural signals at all because it's just too uncertain. So all the information is on board, all the sensors are on board the prosthesis. It's really operating totally in parallel to the human, and it has to perfectly guess what the human's doing all the time. And that's just a very, very challenging problem to solve.
Wow, it does sound like a very challenging problem to solve. And I mean, does it need batteries? Is it, do you need to charge it somehow, or how does that work?
Yeah, so in basic terms, the leg is a motor, a transmission, and a battery. So that's kind of like how it operates. It's just an electric motor with a transmission, and it's packaged in a way that makes it look like a leg. But yeah, it has the second gen version, has an off-the-shelf battery that just sort of slides in. So it charges in a receptacle. It has what's called onboard battery management system, which is safer. We wanted to get away. We used to use just lithium polymer pouch batteries, which are a little riskier. So now we have an off-the-shelf battery that is used. It's integrated. It's a little bit more user-friendly, I would say.
Wow, that's great. Okay, and I mean, is this open source leg going to be a solution for all, the prosthetic leg problems?
I would hope it is like a tool to accelerate, and that's what we get from it. We get brighter minds, people who maybe wouldn't have tested their control strategies on a prosthesis. Now that the barrier is lower, they can test their strategies, start to leverage adjacent fields. That's kind of what I would like to see, is not only the technology getting out to patients, but also sort of a building on global infrastructure for research communities kind of around the world and adjacent communities that just kind of accelerates the machine, gets us answering more questions more quickly, using resources better, using human capital better, things that I think will be like ultimately drivers of success kind of in academia and science and engineering in general.
Okay. And you mentioned the motor before, right? Earlier. Does it have to do anything with drones? I heard something about it, but I didn't quite understand. So how does that work? I mean, drones in a open source. I mean, this is crazy.
So when we were designing the open source leg, one of the decisions we have to make is what motor to use. And recently, the drone industry has created a motor that looks a little bit different than a regular motor. These motors are wide and thin because drones can't have transmissions. So they need to create the torque they need, not by using a transmission, but by increasing the diameter of the motor. So instead, they have these large diameter kind of thin motors, and we leveraged that to reduce the transmission ratio in the design. So now we can not have as high of a transmission ratio. Higher transmission ratios come with challenges. It reduces efficiency, it's harder to package. So we basically leveraged this new style of motor, these motors from the drone industry, for some advantages that open doors on the design side. And that worked very well. And now I'd say it's more common in robotics to be using these motors. They've made a big impact.
Wow, this is really new for me. I mean, especially like I will never thought of using drones for this special project. And what was the biggest technical challenge you managed to solve when it came to implanting the drone into the open source?
Let's see, a lot of challenges. I would say, I guess there's one challenge is specifically around these motors, is that when we first use these, so when you make the motors really large and they tend to produce a lot of torque, they have lots of what's called pole pairs. So they have like a technical attribute to them that can be challenging on the computational side. They're run by a small computer called a drive. And so when motors had this many pole pairs, we couldn't get a drive to use it. The way drones are controlled is different than the way kind of robotic systems are controlled. So there was no electrical hardware to actually what's called commutate these motors. So we partnered with a company that's some friends of mine who were using who were developing drives that could actually use these motors. And that enabled us to kind of like get going into this faster than maybe other people could have, because at first there was no product to actually use these motors. Now there have been many different drives that have come out that can commutate the pole pairs at the speeds we need. But at the time that didn't exist. So that was a big challenge that we solved by leveraging our colleagues at Defy. And a company, Defy is who we've worked really, really closely with, not only on the open source leg and the embedded systems, but also in other aspects of our research. We work very closely with them. They build ankle exoskeletons.
Oh, that's great. Okay. So you're working in between projects, basically. Yeah. When was the first time that you actually tried it? Like what year?
Oh man, that would probably be a long time ago. The first time I walked on it was maybe in 2016 or 2017.
Okay.
But I would say we work also with some collaborators at the Shirley Ryan Ability Lab, a guy named Professor Levi Hargrove. And he's one of the researchers, maybe one of the best researchers that develops these high-level control strategies. So identifying what activity someone is doing. And probably the most memorable experience testing the open source leg was I tested his open source leg in his lab with his controller, identifying what was happening. So I was wearing a bent leg adapter and I was wearing the prosthetic leg under my leg. And then I could walk with it and it would identify when I'm walking, it would walk with me. When I stopped, it would stop. It would let me go upstairs and downstairs, and kind of feeling that intelligence running the leg was pretty special and exciting.
Wow, this is great. And do you have like any time delay, like seconds, 3 seconds or something like that? Or is it like at the same time?
You mean like how fast does it make decisions?
Exactly, yeah.
Yeah, so it makes decisions probably 5 times. It makes these highest level decisions maybe 5 times a second. So that's relatively fast. And then the controllers that are telling within a task what it should do, its instructions for, say, walking, that runs at maybe 500 hertz, so 500 times a second. And then other loops, control loops, would run even faster, maybe 2000 hertz or 1000 hertz.
Wow, this is amazing. This is great.
It's cool stuff.
It's really cool stuff, I will have to say. And I mean, how hard it was for you? Like, have you found any critical challenges when it comes to the procurement process?
Yeah, so we tried, one of the constraints that we kind of put on ourselves when developing this leg is we wanted to minimize the number of vendors or suppliers that are used. So we actually worked really hard to consolidate all the parts that are ordered from kind of like 3 or 4 companies. So in that sense, that wasn't actually, like, the hard part was finding parts that aligned with that philosophy. But once we did that, the procurement process is pretty straightforward. We do most of our machining with machine shops in China, and there have been some challenges getting these tariffs, getting things back and forth. But overall, we are very happy with the quality we get and the parts we get from them. So yeah, I'd say in general, actually maybe one thing is, for the open source leg, we partner with this company, Defy, who I mentioned, who makes these controllers that run on the motors that make them work.
Okay.
Defy can't sell or doesn't sell to certain countries, or they have a kind of a limited set of countries. They're a defense contractor, so they have a limited set of countries that they can interact with. So now let's say we had somebody interested in working with the open source leg who is not from a allowed country, then they can't get access to some of the electrical hardware that they need. So what we did was figure out a way to have it work with the brushless motors drives that come with. We kind of gave them a second option. So we kind of solved that problem a different way. And now we've developed kind of an open source library someone can just download on the internet, and it runs with these a totally separate set of kind of computing and drive hardware. So that was that's kind of a procurement issue, and also speaks to some of the challenges that we've had to overcome, and some of the exciting parts about people around the world being interested. I work with a group in Armenia who just got a grant to develop an open source leg program in Armenia. And that's super exciting.
That's super exciting, because you can also have like a contrast of what they're doing, and especially if you have communication with them, like new developments can come around, right? And last but not least, do you have like any advice for future engineers or people starting on this path?
Oh, definitely. How much time do we have? Just kidding.
Go ahead, go ahead.
I would say the thing that I see, I talk to a lot of students that come in, they're kind of trying to figure out what to do, what they should do with their life. And one thing that I see as like a common or consistent theme or trend is that they're stressed and that they're really concerned about, they got to find kind of the one thing they're meant to do, or the right answer of what their next step is, and they're kind of stressed about it. And I implore them, like, I don't think that's the right way to think of it. You don't want to think there isn't just one thing. There's many things. And if you kind of identify like what you like as a specific type of tools that you like to use, or a type of problem you like to solve, that opens up many options, not usually just one. And I kind of try to get them to think about it that way, and not put so much pressure on themselves. Like, if I was working at a different place, I would probably love it. Like, there are probably things that I would find about that job, assuming it's something reasonably around engineering, that I would really enjoy, and I would focus on that, and I would hopefully find some level of like interest or fulfillment. But yeah, so I kind of talk them through that concept. That's probably my second. That's the first thing. My second thing is, I think the most powerful professional attribute is the ability to convert effort into results. So when you work on something happens. You can navigate a project from A to B, find the path, and execute. And a lot of people, I think, don't really realize that, like, that's the goal. The goal is usually like that. That's what your employer is probably looking, is for you to have that skill. And so like to focus on that, or at least realize that that's a part of being a professional, and maybe being a strong professional. So like focusing on that ability, and not, at least having it on their radar, so that they're tracking like their performance in it. Those are my two like top pieces of advice. You
got them really, really well, like down to earth. Thank you so much, Professor. And I mean, last but not least, I mean, where can we find you? Do you have any social media? I know that you're on LinkedIn. What would be the best way to contact you?
LinkedIn and email. Honestly, email is probably the best. So LinkedIn is I'm on LinkedIn and I post, but I don't check its like communication too much. Okay. I should be on Twitter, but I'm not looking for like other things to do. So okay. I haven't done it. I think my lab will eventually get a Twitter account, but at least for now, it's on LinkedIn. That's
the way to go. Okay, thank you so much. And thank you so much for being here. Remember, guys, that you can also find more information, interesting articles, or interviews just like this one with Elliott directly on our website, controlhub.com/builder-nation. We would love to hear from you. And once again, thank you so much, Elliott, for taking the time and sharing your experiences and being here once again.
Thank you for having me. This was a blast.